All right, let's do 4.3. Oop. Yep, 4.3. It says analyze, so I'm going to do what I do. First of all, we factor. So we can take a 2 out of this and we get 2 times x plus 2 over x minus 1. Then we look for wholes. No factors are equal, so none. So then we look for vertical asymptotes. So that would be at 1. And that's a vertical line, so we write x equal 1. Then we check for oblique or horizontal. Asymptotes. And since the degree of the numerator and the denominator are 1, then we use the ratio of the leading coefficients, which is 2 and 1. So we get y equals 2, and it's horizontal. And then we find x-intercept. Oh, we should do, yeah. And the behavior at the vertical asymptote. Behavior is, since it's a single factor, they go in opposite directions either side of that. And then we do, excuse me, x-intercepts, which means what makes the numerator 0, and that would be a -2. And then we y-intercepts by putting in 0, 4x, and so that'd be 2 times 2 over -1, which is -4. And let's go ahead and graph. So, no holes, vertical asymptote at 1. Horizontal asymptote at y equals 2. And x-intercept at -2, 0. Y-intercept at 0, -4. And they go opposite on either side of this. So I've got all my information on there, so it looks like it goes through -4 here, and it's going this way. And since it would be symmetric on a simple one like this, so there would be another curve up here someplace, coming like that. That's number 10. 13. Factor. Let's see. Well, that doesn't factor. If it was 2x squared, it would factor to x squared plus 1 and x squared plus 1, but 1x squared won't factor. You can put 1, 1, 1 in the quadratic formula and it'll tell you it's i's. It doesn't hit the x-axis. So there's no factors on that. The denominator does factor to x plus 1 and x minus 1. Numerator doesn't factor in the real, so done with the factoring. Are there holes? Since this isn't factor, can't match any of these, so none. So vertical asymptotes. There's going to be one at -1. And since it's a single factor, it's going to be going opposite by it on either side of it. And then one at x equal 1, and again opposite, because it's a single factor, it's not squared. And then we have x-intercepts. Well, since this doesn't factor, if you graph just the numerator, you can see it never hits the x-axis, so there's none. And the denominator for the, no, then for the y-intercepts, we put in 0 for x, and we get 1 over -1, so it's -1. So, oops, that may have been off the screen there. I think it's close, so no holes, because no like factors. This doesn't factor. This does factor to this. Vertical asymptote there and a vertical asymptote there. Each one appears once, so they're opposite. No x-intercepts, because we can't make the numerator be 0. You can graph it and see that it never hits 0. And if you put 0 in for the x's, we get 1 over negative 1. Put it in here, which is negative 1. So the graph would look like vertical asymptote at minus 1, vertical asymptote at plus 1. And it has no x-intercepts, never hits it. It goes through minus 1 on the y-axis. And it has to go opposite by each of those. So if it goes through that point and doesn't cross the x-axis, then it has to go down on this one and down on this one. Now the peak might not be right on the y-axis, but it probably is. And oh, I forgot to do the horizontal asymptote. This is going to be, this is 2 bigger than this, so that's going to be some sort of parabolic shape. And I'm not going to ask you to do one of those, so we don't know. I'm going to skip that. And we're just going to go on with this. It's actually going to approach a parabola and probably something like this. But if it went off here, then it has to come back here and go towards this parabola. And if it went down here, it has to come back on the upside here and then probably go approach a parabola there. So that's roughly what it looks like. This parabolic asymptote is because the degree is 2 more than the denominator. 20. Make sure it's up here far enough. So whole factors. Well, we have the 3's already out. That's denominator factors is x plus 1, x minus 1. So wholes. And no factor matches x, so none. So next is vertical asymptotes. And so we're going to have one at negative 1 and at 1. X equal negative 1 and x equal 1. And horizontal or oblique, well, since the degree of the numerator is less than the denominator, it's going to be y equals 0. Whenever the degree of the denominator is bigger than the numerator, it goes to 0. X-axis, x-intercepts. Well, whatever makes the numerator 0, which is 0. So that would be also a y-intercept. Or you can put 0 in for x, and you get 0 over negative 1, which is 0. So that's the only point we know. So we can graph this. It has no holes. It has a vertical one at minus 1, at plus 1, and a horizontal at y equals 0, and it crosses at 0, 0. And so now we don't know which way it goes by these here, but they do go, since they're single factors, they go opposite on each one. I forgot. No, I did do it on the last one. Okay, so it goes opposite. So now I just have to figure out which way it's going. So now I can test maybe close to it. If I put 1.1 in there, the numerator would be positive. 1.1, this would be positive. 1.1, this would be positive. So it has to be going positive at 1.1. And it gets closer and closer to y equals 0, so it has to go like this. This goes opposite on this vertical one at 1, so it has to come back here. The whole, now it could go back down and be, but it's not a double factor, so it doesn't bounce at 0. So it doesn't go back down, it must keep on going. Which means it has to come back on the bottom side here and go this way. That's 20. 31. So, first of all, factor. Well, these are all factored. And are there holes? No matching factors, so none. Then we go to vertical asymptotes. And so it's at x equal minus 3. and it happens 3 times, so it's going to go opposite. And then oblique or horizontal. Okay, so the degree of the numerator is, it's going to be x times x times x to the third. And the degree of the denominator is going to be x to the third. And they're both going to have a 1 in front of them. And since they're the same degree, we use the ratio of the coefficients. So it's y equals 1. And then x-intercepts is what makes the numerator 0, and that would be 0. And 1, 0. That one happens twice. And the y-intercept is put in 0, and we get 0 times this over that, which is 0. So if I graph this as a vertical at -3, it has a horizontal at y equal 1. It crosses at 0, 0 and at 1, 0. Okay. It doesn't cross out here, so it can't go down to here, so it must come from above and go like this towards this line. And then in the middle here, it does cross here and across here. So, and at this, it has to go the cube, so we have to go 3 times. But it actually bounces at 1 because that's a double, so it crosses here, bounces, and then goes closer. $35. Factor. So I think this factors to, must be 3x and 2x. And if I take 3 times 3, I get 9x squared. And 1 times there is 2x squared. 9 minus 2 is 7. If I could get minus 9 and plus 2. The denominator, this is going to be 2x and x. Got to get 6 and minus 7. Let's see. And they got to add. So if I put 2 here, that'll be 4. And if I put a 3 here, that's 3. 4 plus 3 is 7 if they're both minus. So wholes, is there any matching ones? Yes. So we have a whole, and we can use, let's see, that would be at, if I set 2x minus 3 equal to 0, I get x equals plus 3 divided by 2, 3 halves. So the whole's at 3 halves, and to find the y value, I put 3 halves into what's left. 3 times 3 halves is 9 halves. Plus 1, 9 halves is 4.5, plus 1 is 5.5, divided by 1.5 minus 2 is 1/2. So that's actually 11. So now that's gone. Now I look for the vertical asymptotes. So that's gone, so it's at x equal to. Horizontal or oblique. Okay, so the degree of the numerator and denominator are the same, so it's the ratio of the coefficients. 6 divided by 2 is 3. X-intercepts. Oh, behavior. This happens once, so this is opposite. X-intercepts, if I try to make the numerator 0, I get x equal minus 1 divided by 3. Minus 1/3. Y-intercepts, I put in 0 and I get 1 over negative 2, which is negative 1/2. When I put in 0 for x. So my graph. A whole at 3/2 and 11. So I'll go 2, 4, 6, 8, 10. So 11's here. There's a whole. Vertical at x equal 2. Oops. The whole is at 1.5 there, so it should have been there. A vertical at 2. And they go opposite on this thing. And horizontal at y equal 3. Crosses the x at minus 1/3. Crosses the y at minus 1/2. And so it must go that way. That way. Oh, but it has to go through this hole. Something's wrong here. I'm putting in 3/2. 9/2 plus 1 is 5.5 over, oh, this is minus 1/2. So this is minus 11. So it doesn't go through the hole up there. It goes through 3/2 minus 11, way down there. So it goes through the hole and then on. And so then it would show up over here. And there's the graph. Made a mistake on the minus on that part of it there.